What's up? In this tutorial we're going to go over the basics of breadboarding, setting up an ESP32 microcontroller with a display and a sensor. We go over setting up the IDE Arduino dev environment. We do a little bit of soldering, we do some programming, we got like multimeter action in here, so pretty much, and the wiring as well. So you got all the little facets that set up an electronics project all in one. From this one tutorial, you should be able to branch out and do basically pretty much anything with your electronics. So it's a good introduction. Without further ado, let's get started. So there's something I want to show you guys that I found out the hard way, and maybe you guys won't have to find out the hard way. So I pulled this power adapter from electric piano, and I don't know what this one is, but if you look at these, see, notice that this is the output is 12 volts. And this one is upside down. If you zoom in, that one says that it is what, 9 volts. So I originally ordered this power module here and it said it should be good for 7 to 12 volts, but when I got the board itself it said 7 to 10 on there. So make sure you check what your board says and not what you ordered online, because they might not match. We'll take the positive end and the negative ends. You'll just stick this in here and you'll hold that against there, and I'll try to do this with one hand. I don't know if you guys can see the numbers. Let's see if I can do this. Notice that it's negative. That'll be very important coming up soon. I thought that was a little strange, but I was like, oh, whatever, no big deal. And so I'm sitting here plugging this into the power module, wondering why it's not working. Then eventually I was like, well, maybe it's just a dead power supply. Let's test this other one. Cool, so I didn't hit record, so we'll do that again. Here's the barrel jack of the 12 volt. You can tell it actually looks a little different. So if we plug that in there, grab your multimeter. Ooh, shiny. Touch it there, and it's a positive value. Notice that. The other one was negative, this one is positive. Turns out there's this little detail that's very important that no one really told me. I don't know why they would, but there's positive centeredness and negative centeredness for your barrels, for your power sources. One of them will work and the other one won't, and that depends on what kind of setup you have. Usually the positive centered ones will work. So if you plug it in and it's not working, and you got your multimeter, test that it's the right polarity or sign or currents going in the right direction, whatever you want to call that. And yeah, that'll save you a headache. Fucking took me a while to figure that out, and I ended up, like I said, frying the board just a pinch. Got a little hot, but that's okay. It still works kind of, mostly, hopefully. Alright, so I got two little breadboards, but here's the power module I got. You can see where it says 7 to 10 volts. That was supposed to be 7 to 12 volts. And I can tell you from experience that if you plug 12 volts up to it, it will start to smoke, and that's not good, and it'll happen fast. Alright, here's our OLED display. You just know that it has the ground, the power, and all the usual stuff. But I got a 2-pack of these in case I fried one, and I have yet to fry this one. So that's the display. Here's our gyroscope. This is our MPU 6050. You can take a close look at that. You can see these little symbols here for direction, pitch, roll, and yaw. It's got its little chips. From what I can tell, we only need the top 4 ports or slots or pin points. I don't know what the other ones do yet, but I'm sure at some point I'll figure it out. Okay, this is the LDO. This is like a voltage drop down or step down regulator thing. It converts like from 12 volts to 3.3 or maybe 5 volts to 3.3. Basically, I'm using this to get any voltage that we could have down to a safer voltage of 3.3 volts. Here we have the ESP32. I've liked this development board or microcontroller so far. I've only used it twice, or this is technically the second project I'd be using it in, but it's got Wi-Fi, decently powerful for its size. It'll do everything we need to do. Alright, so I decided I was going to solder these header wires into these little chips because trying to like hold this in here on the breadboard or with the wires and you have to like bend it and keep pressure like that while trying to move things is a pain in the ass, so I'm actually going to solder them. The LDOs did it, had them set up like this where the pins are on the bottom. Probably going to do the same just to keep things uniform and also keep these easy to get to. Straight to the face every time. Alright, so this is a breadboard. You can think of it as like an electrical wiring grid where these side wires or grids or, I don't know, rails I guess they're called, go all the way down. And so you have a positive and negative sides, which is the negative is the ground. So as an example, like these horizontal ones go all the way across. So if you take a power pin or cable and plug it into the positive and say you plug it to here, notice how I jumped from, so imagine this is getting power. This now provides power to the entire row that it's connected to. Although I'm not 100% sure if this one goes all the way across or not. It kind of has this weird marker here, I'm not sure. But you get the idea. So like you can jump power from here to anything over here. So if I wanted to take power from this to here, I can take it to here, plug in here in this G, except these pins kind of suck. And then I could take it all the way down to here if I wanted to. And now anything over here is getting power. So that's just kind of a little overview of how the breadboard works and connects everything. Okay, so for the actual project, we'd want to set up the battery with our step-down LDO and all that jazz. But for the purpose of this tutorial, just hook up your ESP32 to your breadboard if you got one and you're following along. Otherwise, just enjoy the show. Make sure you've got a USB cable that can connect to your computer. Plug that in, and we'll plug that into here. If I can turn this. Okay, we have power. So next thing we want to do is get the display hooked up so we can make sure that it's working, because I'm not sure. You can check these these solders, and just make sure it's working. I forget which way is up, so it might be upside down. So plug that into your breadboard. Where do we want it? Let's put it up here. Make sure you leave slots so that you can get your pins in, so that you can plug in if that makes sense. We're going to want to get power to it, and to do that we want to pull power from our controller, which is the 3.3 volt section. So track down a wire. I'm gonna go with these red. You want dual males. Can you see that? Plug into our 3.3. Oh, I pushed the boot button. Shoot. This pin. And before we do that, we're gonna want to ground it. I don't know why, but I always try to ground things before I put power in. Maybe in a previous life I got fried for not doing that. So if you can see where the ground pin is, oh god, this is a female. We need dual males. Come on now. You want to try to color coordinate it too. if you can. I usually like to do like blacks and browns as the grounds, sometimes like a yellow. That sounds kind of racist, but it, you know, it's not. Or is it? Here we go. Ground goes in there. Power, we got our red into power. This is really hard to do with one hand and watching through the camera. So the SCK and the SDA, those are actually our video thingies. So we got to figure out, I can't remember. There's two pins we want to plug them into on here. One's 22 and the other one is 19. And I have to actually look at a diagram really quick to make sure which one is which. I think 22 goes to the SCK, which if you ask ChatGPT, it'll tell you SLK. Close enough. So, but that's 23. Make sure you get it into the right slot. Otherwise, it's not going to work. 22 goes to SCK. Maybe I should put this flat on the table and then video from above instead of holding the whole thing. I also probably should have made more room. Let's scooch this guy over a little bit. Come on, get in your hole. It's funny, going from doing stuff in Unreal Engine where everything's digital to like actually having to push the pins in. Bit of a change, but all the wiring is familiar. You know what I mean? Cool. I think that's the basic wiring. I'm gonna check a diagram real quick. Be right back. Okay, good thing I actually checked the diagram because the SDA is actually pin 21 and I told you guys I think 19, so we gotta rewire that. So also fun stuff, I just realized that when I put this back in over here it was off by 1, and so it was like feeding power in or something, I don't know, but this was getting quite warm, so hopefully it still works. Anyway, moving on, we want to plug that one pin in, make sure you got the dual males and females. What did it say, 21? That looks like right there. I literally can't see the screen because of the gripper from the camera stand. Ooh, nice. Okay, next step is to wire up our MPU 6050, which is the accelerometer, gyroscope. You can see how there's the VCC, which is voltage, and the ground, and we need the SCL and the SDA, just like the display, which is probably where it communicates the data. So I'm going to plug this over here, because that just seems nice and convenient, or maybe down here. Get in your hole. Sometimes it's kind of hard to get that in there and you don't want to break anything or smash your fingers. Okay, so I'm going to pull, if I can get a decent colored pin that's not too long, I'm going to take orange. This power from this 3.3 volt, I'm going to take that, I'm going to put it into this over here. It's kind of loose. I'm going to take the ground. Use black for the ground, so hopefully you guys can see ground in the blue. We're going to feed that into our ground row, which connects to here. I'm going to jump anywhere in the power line from here into our power. So to make that make sense, the power is going to go in through this port for now. It's going to go directly into the display, which I could have fed that wire, which I can take this out now actually, and I can just do a short little jump. Okay, so I mean, I didn't have to do this, but I'm just doing it as a demonstration. Going to pull from the power rail, plug that into here. So now you guys kind of understand that this rail goes all the way up and down and will feed into there because we're feeding this rail down here and we're also, so yeah, does that make sense? Like power into the USB, this jumps to the rail, which I'm going to make it go here. This is pulling from this rail into here, and this is pulling from the rail into there. This ground is weirdly connected to this ground. Uh-oh. I think I actually have a mistake here. I didn't ground this to the actual ground, so we gotta do that. That would have been bad. So make sure you ground your stuff, even if they're just LEDs. Okay, so here's the ground. And I'm gonna also feed that into the blue. And now you can see how things can get a little messy. So that's that setup. So we have power and ground into our accelerometer. Now we need the SDA and the SCL, which is pins 22 and 21 again. We're gonna go purple and blue. That's what's on there, and I dig that. Yeah, so here's SCL. If you don't know where anything goes, you look up diagrams, but honestly, ask one of the AIs and it'll help you out. It's like better than Google search these days. SCL goes into pin 22, which is up here, because that's also going in to our other display. So now we've got two there. Let's do our SDA. I guess I didn't have to be this close to the board, and that'll go into pin 21, which is this one. Man, I made those. Did I make those both blue? That's kind of annoying. No, I made one blue and one green. Okay, that's good. Get in there. Get in there. All right. So we are wired up. We're grounded. We have power. Let's plug it in and hope for the best. Okay, so here's our USB. This is hooked up into the computer. I'm going to plug this in. And of course, now I can't even get to it, can I? I would do that. So don't be an idiot like me and block the port for your stuff. I don't like that these are crisscrossing personally, but it is what it is. So now we got room. Get in your hole. Get in your hole. Bad design. Now I'm thinking I should have moved this down here and then moved those up there. So layout matters. Try to think ahead. I just wanted the board more centered. Okay, that's good sign. That turned on. We got red light. That's good sign. That still works. Now it's time to upload our code. You got to set up your Arduino IDE. We need to set up our IDE, which is the Arduino IDE. So if you don't have Arduino, download it. It's this little figurehead thing. You can Google that on your own time. Some things you need to do, you need to go into Tools, you need to go into Board Manager. You're going to want to download the ESP32 boards by Adafruit or Arduino or Espressif. I think I have Espressif, so if you type in ESP32. And yeah, so I have the one by Espressif Systems downloaded. I think either will work, but this is what I got. For this one, since we're using the, something U6050. It's not GPU. Hold up. MPU. So type that in. That's not supposed to be a comma. MPU. Come on now. Search. Maybe that's not in boards. Maybe I'm supposed to look in libraries. Manage libraries. Yeah, libraries. Okay, then go to manage libraries in your tools. Sorry, I got something in my eye. Here we go. Manage libraries. Search for MPU 6050. And which one did I use? I used the electronic cats. That was recommended by ChatGPT, oddly enough, but I'm sure any of these work. Which kind of makes you wonder if like old forums highly recommended certain ones and now those have been absorbed by the AI. artifacts of the old internet. Okay, so what else do we want? We have a display, so you're gonna want the library for the display. So it's called the SSD, which sounds like solid state drive, but 1306. Excuse me. And I have the Adafruit SSD 1306 library installed, so go with that. One more thing. What is it? I think if you go File Preferences, yeah, you want to add additional board managers for your ESP32 board. I'm using this file URL right here where it's like the Espressif one, package ESP32 index.json. I can add that to the description if I remember. Otherwise, you just want to ask ChatGPT which Espressif board manager, how to set this up. It'll give you this link or one like it. I'll add it in the bottom. Remind me if I forget. Okay, so that's the basic setup for your environment. Now you've got Arduino open and with the sketch. We need to add the port. Yes, so go to port, COM3 is hopefully showing up. If it's not showing up, you're gonna have to Google how to fix that. That's its own thing. And then if you go to board, ESP32, I go to ESP32 dev module. Boom. You'll see in the bottom right, ESP32 dev, and that's the basic setup to get the environment ready to add code. Oh, you know what I mean? All right. Okay, so next step, we want to just get a basic display on here. Literally, you just Google this or type it into whatever AI chatbot you're using to solve all your problems. But for today, for the sake of this tutorial, we'll do it by hand. I'm literally going to look at the screen because this is what's called boilerplate code. It's not something you would ever want to manually type in if you didn't have to, because it's like, why would you do things that are like, I don't know, unnecessary and basic. So basically we're adding our includes. I don't know why that didn't show up. Hold on. The Adafruit SSD 1306.h. These are those libraries that we just added. And now we got to initialize our display, which is this little call here. SSD 1306, right? Type display 128 by 32, unless you got something else. If you have something else, you're gonna have to specify it for that. Wire -1. I don't know why I'm actually making this tutorial, because it's like, I don't know how many of you guys are out there who would actually want to build this, or if you just want to like watch. Okay, so now we want to actually set up the display, and this is boilerplate code again. Like, once you have this copied down, you can use it over and over again. I didn't even hand type this when I was doing it, because I've been doing this stuff long enough to know what is necessary for us to do and what is like, let the machine do it, because we don't need to reinvent the wheel a million times over and over again. It's annoying. Yeah. Okay. So that's the begin. We want to clear it. You don't have to type that, but it's just good practice. So we're going to set the text size. I'm going to set it to 2. You can set it to 1. 3 is too big for this little guy, but 1 and 2 kind of fit. Display, set text color, white. That's kind of racist, but you know, it actually is blue because we have a blue display. Display, I don't even think this has colors other than blue right now. Set cursor, 0, 0. I gotta move my breadboard. I'm like typing in a weird way that's causing tension. I'm also used to having like Vim controls in my IDEs, so it's kind of slowing me down not having that. Okay, print line. Here's our message. I'm gonna actually put a space here, so this is like, ooh, a double space. That's ugly. This is our message we want to send. It's like, enter your text here. What's up, YouTube? Blah. Actually, what's up? Okay. Cool. Semicolons. Where's my mouse? I just got done typing Python recently, and I hate it. No semicolons, no little curly brackets, so you gotta like take out your tape measure and your freaking like angle finder to make sure everything's lined up. It's so dumb. Like, how lazy can you be that you don't want to add semicolons? And I heard they made Python though, which is like Python with braces. Okay, now here's our little call from our library. If you download the correct libraries, start scroll left. Oh, I hate that they did that all lowercase too, which I like camel case. Personal gripes. Oop, 0x00, so that's like the left page, and this 03 is the right page. Probably have to look that up inside the library itself to know what it means, but we don't need to do that. We already just know it works. So you have the code, it's in there. You got your breadboard, your display's probably not on. Oh, I hit save. And you got it wired up, hopefully, if you're actually following along. Otherwise, you're just watching. That's what we got. And then you upload when you're hooked up. So right now I hit upload. It's compiling. Compiler, hell yeah. What is it? Void setup. Did you mean that? Probably. What's different? SS3. Switch app VCC. Did you mean switch app VCC? I mean, what's the difference? Do you guys see the difference? I don't see the difference. Was not declared in the scope. Did you mean sure? Copy this little guy, because apparently it's different from what I typed, which I don't feel like it's different. Oh yeah, it's totally different. What was different? Switch. Oh, there's an extra C. Switch cap. Okay, recompiling. I got a 9-volt battery. Let's test it. Yep, it works. Oh, hey, it worked. Kind of. It kind of worked. Maybe you have to change OXO3 to be longer. So anyways, I don't know if you can see that. It kind of worked. It's not capturing all the letters. We probably need to shorten the message or increase the start scroll left to be like more inclusive. Yeah. I don't know if you can see that. Okay. That's the basics of getting your microcontroller hooked up to your Arduino dev kit on your computer, wiring it up to a display, and then passing the code into the controller, which updates the display. That's like, from there you can do a lot. Like once you got that down, the world's your oyster. We're ready to cook with gas. All right, so now we want to test our little GPU accelerator, our gyroscope, which is the, I keep calling it a GPU, but it's an MPU 6050. So here's the code for a basic setup. If you want, you can screenshot or pause the video, type it in manually, or just Google your own version. Here's the top half. And actually that's all of it. I got all of it on one page. Very cool. So that'll just display stuff. All right, let's go. So I'm going to upload that code that we saw earlier. I'm not even going to switch to the screen cap, but we can sit here and watch the compiling, see if it works out. If you guys like this mug, it's my me mug, my electric gaze mug. It's for sale if you want to buy one. Will it work the first time? Yes, because it's technically not the first time. Ooh. Anyway, so yeah, that's cool. The display's updating with information from our accelerometer. It's the Gyro X. I don't really understand what number that is. It's probably like a combination of all three, giving you a scalar value. But the Excel X, Y, and Z seem to work. I'm not sure what Z is doing. Maybe if I jiggle it. Cool. So, that is the basics of this tutorial. I think I'm going to stop there. There's obviously more that I want to do. I want to get this into like a tight little package. That sounds weird. But that's the basics of how to wire up a breadboard, connect it to a microcontroller, upload code from your PC, and get a display to show something. Congratulations, you're now a master of electronics. So that's going to conclude this tutorial. I hope it helps you guys, or at least you found it interesting. I mean, I always wondered how to do this, and now I kind of know how, and the veil has been lifted, and it's like cyberpunk time, dude. Time to make some robotic arms. So if you like that tutorial, you could check out my other electronics tutorial where we build this light tubes, these LED light tubes. They're kind of moving right now. It just took them a second. I thought it was like frozen. I also do a lot of Unreal Engine stuff because that's kind of like my main thing, but I kind of wanted to branch out for a little bit, and Unreal Engine blueprints is a lot like hooking up wires, so there's some overlap there. If you're like more from the electronics wiring side, come check out the game dev stuff. Do it!